Hello and welcome to adding rational expressions. Remember adding fractions? Suppose I want to add 3/4 plus 2/5. Well, in order to do this, I need, that's right, common denominators. And for this, 4 and 5 have no common factors, so my common denominator is going to be 20, and I need to multiply this first fraction by 5/5, and this second fraction by 4/4. And that is going to give me 15/20 plus 8/20, and that equals 23/20. Here in algebra land, we like our improper fractions. I can't simplify that, so I'm going to leave the answer just like that. So let's go on and look at adding some rational expressions. They're a little more complicated than these simple variables. And our first one is going to already have a common denominator, and then we'll move on to putting them in common denominators so that we can add them. All right, here's our first adding rational expressions. And our denominators are the same, so we're going to be able to just add these two binomials. So, my denominator is going to be x squared plus 5x plus 6. And up here I'm going to have 2x plus 5x is 7x, and minus 5 plus minus 3 is minus 8, and that's great, but I'm not all done because I still need to know what the restrictions might be on my variable. So let's factor, even though we already have a common denominator. Two numbers that multiply to 6 and add to 5, x plus 3, x plus 2. So that means that x is not equal to -2 or -3. Rewrite that over here by my final answer, and there we go. Easy peasy. All right, next problem. We do not have like denominators, but I think it's not going to be hard to get into common denominators here. Let's start by factoring this first one. We seem to have even numbers here and here, so let's factor out this 2 times x plus 4. That means that my common denominator is indeed 2x plus 8, and my variable restriction is going to be x not equal to -4. So let's multiply this second fraction by 2/2, and that's going to give me 5/2x plus 8 plus 12/2x plus 8. So we multiply the 2 times the x and the 4, and that gives me 17/2x plus 8. Once again, not too difficult. Let's move on to our third example. All right, there's nothing like about our denominators here. Let's set up our variable restrictions. These not going to be equal to -2 or -1. But I'm going to have to multiply this by v plus 1 over v plus 1, and I'm going to have to multiply this by v plus 2 over v plus 2. So let's set that up. This is going to be multiplied by v minus 3 over v plus 2. And we're going to add that to 6v over v plus 1 times v plus 2 over v plus 2. If you don't remember how to do this multiplication, remember that you can always set up a little tic-tac-toe grid, v plus 1, v plus 2. We set this up nicely as a grid, and I get v times v is v squared, v times 1 is v, v times 2 is 2v, and 2 times 1 is 2. And then I just collect up my like terms here. 2v plus v is 3v, and I get v squared plus 3v plus 2. So we also have to do that for this one here. We can just look at all of our multiplications like that. You can use FOIL, first, inner, outer, last. However you want to do it, you set up grids like this for all of them. We're not going to do that here. I'm just going to look at this multiplication for the top. The bottom we have done as v squared plus 3v plus 2. For the top, I'm going to get v squared minus 2v minus 3. And over here, my denominator will be common, v squared plus 3v plus 2. And on the top, I just need to distribute here, 6v squared plus 12v. Now, I'm just going to need to collect everything up over my denominator. I have v squared plus 6v squared, that's 7v squared. I have minus 2v plus 12v, that's plus 10v. And I have minus 3. So don't forget your variable restrictions here. V is not equal to -2 or -1 because we can never have division by 0. And that completes example 3. This video is getting long, so we'll take the fourth example to another video.